Hello, I'm Daniel Ali Hosseini. First of all, I must thank the organizers for giving us a chance of remote presentation. This is joint work with Ehsan Montahai under supervision of Mahdi Soleimani Baghshah from the Sharif University of Technology. By the progress of the deep learning methods, in recent years, evaluating generative models have been a challenging task. While there exist several metrics in computer vision to evaluate these models, the existing text generation evaluation metrics are not much comprehensive and have their shortcomings. In this paper, we have shown that in order to have a better identification of model characteristics, both the quality and diversity of its samples must be evaluated, especially in the unconditional text generation tasks. Here is the table of the contents. I will first introduce the existing metrics and their shortcomings, and then three more metrics are proposed and the experimental results in the end. The existing metrics. The first one is an n-gram-based commonly used metric called BLEU. Actually, it matches each sentence individually with the whole test samples as a reference set. By doing this scenario for each sample of the model and then averaging these scores will give us a BLEU score. As can be verified, it does not matter that the model is just generating one high-quality sample, and a wide range of reference samples are missed. So it is considering only the quality and not the diversity. Since the BLEU score evaluates just the quality and also the human evaluation of the diversity is not much straightforward, there is another metric called self-BLEU, which is based on the BLEU similarity of each sentence individually to the others. It is obvious that a set of entirely random generated sentences will get the best scores in the self-BLEU. Therefore, it evaluates the diversity and not the quality. But the likelihood, as we assume that the test samples themselves have both quality and diversity, if a model has missed some patterns due to the lack of either quality or diversity, the probability of test samples with the lower values in the model. Alright, it seems that the likelihood evaluates both diversity and quality. So what's the problem with it? The problem is that it does not assess the samples of the model. In other words, it does not assess models in free-running mode. To compute the probability of a sentence in a model, we usually decompose it to the probability of each word given the previous ones. In the likelihood evaluation, these given words are from the ground truth sentences, and we don't know how a model will perform in the test time. This phenomenon is closely related to the so-called exposure bias problem of MLE. Another point is the high sensitivity of the likelihood to the mode collapse problem, which GANs suffer from, and so it is not a fair metric for them. Our principal goal in language modeling is to learn a model generating sentences with high probability in real language. But as we don't have the real language probability distribution, we can assume a random language model called Oracle, for example, a random LSTM, which is to be learned by its samples. The probability of model samples in the Oracle will be another metric called the Oracle NL. How much your sentences are more qualified, they will have higher probability in the Oracle. And so the Oracle NL considers just the quality and ignores the coverage. There exists a statement that is a trade-off between diversity and quality. How much you sharpen a distribution, it will increases the quality of samples and decreases their diversity and vice versa. To exploit this behavior of models, we have done several experiments and created the spectrum of a quality-diversity trade-off by the well-known temperature parameter technique. In this figure, each point is for one temperature, and the vertical axis denotes the diversity, and the horizontal one denotes the quality, while lower values in both axes are better. As you can see, for a fixed diversity, the MLE, the blue one, has higher quality compared to the GANs. So the GANs are not that much powerful in keeping both quality and diversity, which some other works have also stated. So instead of evaluating models with different temperatures and plotting these figures, it is desired to have a jointly measuring quality and diversity metric. It should be noted that evaluating each point in this spectrum is the result of much time-consuming metric evaluations like the BLEU and self-BLEU. Moreover, there may be several distribution sharpening methods, or in the worst case, we don't have access to the probability distribution of a model to modify it. So it is desired to be independent of these procedures. So here we have proposed three more metrics to cover those aspects. First one is an n-gram based metric called MS-Jacquard. Unlike BLEU that sees each samples of the model individually, by comparing the whole samples of the model with the reference set, we can evaluate both the quality and the coverage of the model. For a fixed n, we create two n-gram multisets, one for the model samples and the other one for the test. The Jaccard similarity between these two multisets will give us a score, and the geometric mean over all n's will result in the final MS-Jaccard score. The Jaccard similarity score between two sets is the ratio of the size of their intersection to their union. What will be changed for multisets is that the intersection is interpreted as the minimum occurrence of n-grams in each multiset and the union as the maximum of them. So, any n-gram mismatch due to the lack of quality or diversity will make this intersection smaller and the Jaccard score will be a lower one. Therefore, it considers both the quality and the diversity. Another metric is the Frechet-Baird distance, which is inspired by the Frechet inception distance, or FID, the most popular image generation metric, which uses a highly deep pre-trained model. As it extracts valuable features, which is shown by various tasks, the distance between the test samples and model samples in the feature space will give us a metric. The FID first transforms test and model samples into the feature space, then a Gaussian distribution is fitted to each of them. And finally, the Frechet or Wasserstein 2 distance between these Gaussians is computed in a closed form solution. The FPD that we have proposed is the same as FID, but the feature extractor is the BERT. BERT is a pre-trained language representation model recently introduced by Google. It extracts rich features from the sentences, including their meaning. And so the FPD is expected to assess the semantic validity of generated samples as well as the other aspects. And the last one is for Oracle-based configuration. In this setting, we have both Oracle and model distribution. So instead of having just test NLL or Oracle NLL, we can approximate a wide range of distances as a comparison tool. We have chosen a well-known distance called Bhattacharya distance, if I pronounce it correctly, and we have proposed estimation for it. Since it is a distance, we expect it to evaluate all aspects of two distributions, including both quality and diversity. And the experimental results. We have trained several recently proposed GAN-based models as well as the MLE. There were 3 real-world datasets and 1 for the Oracle training setting. Here are the FPD and the MS-Jaccard scores for the COCO image captions dataset. If we compare the orderings of the models in the spectrum with the right charts, these orderings are almost always consistent. For example, the ordering in the charts is purple, green, blue, and orange, which is the same as the quality diversity spectrum orderings. Here is the same scenario for the Oracle training mode for the Bhattacharya, and again the orderings are the same. We have also computed the correlations of the proposed metrics with the previous ones for real datasets. Since the FPD and MS-Jaccard, both of them are considering quality and diversity, we may expect them to be more correlated with each other. Here this has happened, they are most correlated while having completely different characteristics. On the other side, the NLL is most correlated with the FPD and the MS-Jaccard as well. To sum up, we targeted evaluating text generation models and its metrics. First of all, existing metrics and their shortcomings in jointly considering quality and diversity were introduced. Moreover, to resolve these issues, 3 more metrics were proposed. We're glad to receive your questions and thanks for your attention.